I'm going to allow people to unmute themselves, but please do respect that everybody's turn in making questions. So if you want to ask a question or have some opinion to bring up on the table, just raise your hand as Ben is doing right now, and we can take it from there. So let me first of all allow that anybody can unmute. So I think, well, Ben is actually going to start then. Please, Ben.
Yeah, thanks. I mean, firstly, thanks for both the great talks, right? But my general question, and I'd be really interested to hear what you think, but also what everyone else thinks, is you know, it sounds so good. It sounds like a very, you know, interesting language, but what will be the barriers that you see at this point to move, for people to move over? What's going to stop people moving to Julia, in your opinion?
So if I can speak from my own experience, for me, the biggest thing was initially not being able to read my data. And that was a bit of threshold to implement the reader for that file format. But that was the biggest hurdle for me. I think the other thing is ecosystem. You can't have people in collaborations try out 20 different languages, right? The collaboration falls apart. So, you know, at the moment, the collaborations are using 2 languages, C++ and Python. At some point, this is going to have a limit. If the collaboration decides as a collaboration to adopt Python, I think that would be useful. But if you start writing Julia code and then you move on and nobody can maintain it, that's not useful. So I think that is in these large high energy physics collaborations, I think that I see the biggest obstacle to adoption.
Yeah, I think, if I can sort of reply, like, I think that's been one of the things we felt within PyHEP. It was interesting. I think we've played a good role of helping build and bring people together within high energy physics to you know, improve Python support. And I think something like you're saying, I think you'll increase the support, or increase the accessibility to it a lot if you can really make sure that the community is working together on it.
Now, having said that, I mean, the syntax between Python and Julia is a lot closer than some of these other languages. We've had examples with, you know, people trying Java before, and they're really, the interoperability was bad, and the only reasonable way to get this working is everybody would have had to implement everything in Java, and it's just that's just a non-starter. So yeah, I think that would be the obstacle. I think I think it would be a good choice. It's probably not too much overhead to add this, but the collaborations need to decide for themselves how much additional maintenance burden they want to impose.
Yeah, allow me to build my position, just to make a comment. Indeed, I think you mentioned the support of languages. It is for sure true that within the LHC experiments, which are big experiments, C++ and Python are fully supported, in the sense that probably it's the case that everybody except maybe Alice are configuring their applications throughout the chain in Python. So that's really built into it, and I see there will be a large moment. That will be quite tricky to change that right now, because we're going to start run 3 and there are many other priorities, as everybody mentions. Now, where I see Julia could come into play would be naturally from the analysis side. So from the end of the chain, so to speak, which is exactly what happened to Python. So that I find interesting, especially for some of us who are old enough that I remember the move from Fortran to C++, because I did all my PhD in Fortran. Yeah, I think we will have a shift at some point. There will be a cultural change, and there will be some first explorers as yourselves in Julia. This is already happening, and probably, as I think Ben was mentioning in some chat yesterday, that the switch, if that's going to happen at some point, and I also see problems with that change, by the way, but that will probably happen quicker than it happened in the past, because we have learned a lot, especially from looking a little bit outside ourselves. We were not looking into the data science world. I always tell people that don't forget there's about 50 million data scientists in the world, and many of them are using Python. That's why the system is what it is, right? and this is a big TGV or a big plane if you want. So, I'm completely convinced, although I'm super enthusiastic about Python, that there is an interest in Julia. So I'll be very interested to hear what others think in those respects, having in mind all these constraints. So Philippe, you have a quick, please go ahead.
Yeah, I want to add this up. So I agree on you with you that first thing that can be done is for the analysis, and for this we need to provide tools and first things to be able to read the root files in an efficient way, and maybe plus you also to have a binding to root, because then you have all the tools that you need. I mean, what happens for Pythons? But it's too late for LHC, but it's maybe the right time for HLLC. And if we start using for the analysis and probably in the future for HLLCs, and it will be used for reconstruction code.
And there are many other experiments. If you a few colorful plots from the participants, you will see that we're talking about 50 experiments that at some point connected or registered to PyHEP, for example. So it's not just LHC. Of course, it's a big 10,000 people roughly speaking, a bit over that. But there's many other collaborations where the threshold is probably much lower. Ben, you want to take over from that?
Yeah, I'm conscious that it's so far just the four of us discussing. It'd be nice. I want to give others a chance as well, but I wanted to add another point, which is one of the things that's interesting with Julia is that whereas Python is the transition from C++ to Python is maybe easier to write or nicer to work with. It's easier to teach and so on. But I think historically at least was slower than C++. And so what you actually see now is still a lot of our Python libraries actually under the hood use C++. What would be interesting is if Julia is actually going to give us the opposite, because actually it's if it can be as quick as C++, you could have packages that are actually written in Julia, but then still get used from Python frameworks. So the transition to Julia could actually look very different to what the transition away from C++ to Python looked like. It may actually come in that sort of it could at least come in that way. And that was it. I'll take my hand down.
Well, Gordon is next. Maybe that's a follow-up. Please, Gordon.
Yeah. So one of the, I think it was, there was this workshop in Amsterdam, and I can't remember. It was an analysis ecosystem workshop. I can't remember the exact year. I want to say it was 2019. Maybe it was 2018.
No, 16.
Oh, 16. Okay. All right, so yes, a little while ago. But one of the things that came out of that was, in discussing the Python ecosystem, was how crucial it was to build these things we called back then bridges and tunnels. And this is sort of you already referred to it as one of the, Jan, as one of the things that you were having some trepidation about with Julia.
No, you muted yourself, Gordon. You muted. The sound is gone.
My back now.
Yeah.
Yeah. Sorry about that. My battery died, and I was ignoring the out of battery warnings to my detriment there. But anyway, these bridges and tunnels as a specific target for development. So, for example, uproot and awkward in the Python ecosystem, you might be able to classify under these. And these are enablers. And the idea is not that you start building up the whole HEP ecosystem in Python, but rather you provide the bridge between the current ecosystem and the Julia ecosystem, for example. And I think in Python, that's been quite successful. And there's certainly some features in Julia which I think are superior to Python, and specifically the just-in-time compilation. So I'm very eager to see this move forward. And with the approach of taking advantage of the Julia ecosystem and building bridges or tunnels to the current HEP ecosystem, be it the Python or the C++ or direct root loading, I think could be quite powerful.
Yeah, I agree with that. And so that's why I started with the file format. You know, once you can read your files, then you're at least somewhat decoupled from all of this other stuff, and you can start playing around. And that's why I started with this LCIO binding first. And so just on that interoperability again, so there are these ways to do the boost Python bindings. There's also a very interesting discussion going on right now about, so there is a compiler called cxx.jl that is kind of falling behind a little bit the Julia development. So this was a very easy way to directly call into C++ libraries. So Philip has shown you a way to call into C libraries, but there, of course, all the symbols are easy to understand. And with C++, you always have the problem with the name angling, and you need different ways to call into these C++ libraries. And so there's a very interesting discussion going on right now about using CPPYY to interface C++ and Julia directly, so that you maybe can try things out without having to write this boilerplate code for the wrappers.
I think that's an interesting point indeed. Yeah, I see Thomas is there, and maybe you have some complementary points of view also from coming from a completely non-LHC experiment. So that very welcome that you're joining. Hi.
Thank you, Eduardo. Yes, I just wanted to first second Jan's and others' comments about once you can read your files, once you have this I/O problem solved for a specific language, then I think you have basically all the stuff you need to do your analysis. But I think for myself, what I have experienced with Julia, so okay, I'm a bit biased. I started using Julia when it was version 0.3 or so, 5-6 years ago. I don't remember. So I played a lot with it, but I'm also an experienced Python developer, and I maintain a lot of packages for low-level and also high-level analysis for our experiment, KM3net. And the things which I was constantly fighting over the years was always maintaining these packages which are combined with Python and different technologies to make them fast. So we went through many transitions of making this thing fast. So things actually are libraries. We always suffered from this issue. I think this is at least what I have heard. It's always present in many different experiments where you have these one part of the scientists who are the older parts, or to say it like this, we are used to work with for example, Root, the C++ frameworks, Fortran, and don't want to learn anything new. And this other part, the newcomers who are willing to learn new things, who use Python, etc. So we always try to keep up with this Python thing and implement it, and have used many things to accelerate stuff from number and then all the other stuff you can think about, PyPy, etc. And the main point what I want to say is that maintaining all this glue code over the years was a horrible experience for me, because of course the more things you have as a dependency in your library, the more ecosystems you also have to maintain, and things are changing. That's inevitable. So if you're using something now, next year it will change, and no matter what you do, things will move on. And if you have to maintain different languages and different package systems which are work together, then this will cost a lot of things. So actually we have spent a lot of time in rewriting things because someone used IronPython, or someone used some Cython or C-compiled stuff using some bridges and software which is not maintained anymore. And this is where I think Julia is really nice, because stuff which I wrote back then, even if because Julia has evolved from version 0.3 to 1.61 now, many things from 5 years ago still work, because not much has been changed there. So it's just one ecosystem, and the algorithms and the high level part are written in the same language. So yeah, but that's just my 2 cents which I wanted to tell you. Thanks.
Thanks. Before I pass it on to Wim, profiting from that you're here, and you are from KM3net, so a small experiment compared to the big LHC mammoths. But so how do people say, knowing also that you have been developing packages in Python and Julia. How is well, if there's an uptake of Julia compared to Python in KM3net, or maybe some other experiments you are aware of? How are things in there?
Okay, so I had some crackings in the audio, but I think you asked how Julia is used in KM3net, or how is this perceived?
Yeah, exactly. What's the uptake? Because KM3net is a smaller experiment than this big experiment, so the threshold is probably lower as well. It's easier to change things and try different stuff. So
yes,
it would be interesting to know how that works for you.
Yeah, so we are in an early phase of the experiment, to be honest, which means that you can play a lot more around. And luckily, I have many nice colleagues and professors who are very open to try out new things. And Julia is starting to pick up, but to be honest, I feel like where Python was like 6 or 7 years ago in our experiment. So it was just by a small group of people. They see that this is something which is worthy to try out or to build upon, but it's not really picking up much attraction. So we have a small framework where we can read most of our data. I use it. I built the whole monitoring system upon it. So I use Python and Julia for the monitoring system, which I built several years ago, and still maintaining it. There is reconstruction algorithms written in Julia, and also some other libraries like neutrino oscillation packages, etc. But it's only a small part. So this is something which still needs to shift. I think it only picks up when more people are joining this train. But to me, it feels like Python is this big, heavy train which is just going, and people kind of ignore the stuff that we are using the wrong language, in my opinion, for the purpose. For me, sorry to divert just a few seconds, to me it was like I used Vim for like 25 years, and I always refused to use Emacs because I was sure that Vim is the editor of choice. And at some point I just saw that Emacs is objectively the better software. And I was fighting Vim all the time with all kinds of plugins to make it feel like Emacs and to have this all these features which are already built in an Emacs. And I feel like it's the same with Python. I'm constantly fighting with performance. I'm fighting with writing high-level API code, and just switching to a better tool to have all this in one package is better. But as always, new things just need to get more attraction, and people have to try it out, and that's it. And I think what we said before, that it's nice that you can use Julia from Python and you can use Python from Julia. So both sides are possible, and calling C from Julia is really just a no-brainer without overhead. I think that makes it maybe a bit much easier, but who knows?
Yeah. Okay. Yeah. Thanks. That was very comprehensive. Thank you so much. Vim is probably very eager by now to jump into the discussion, so I'll let him continue. Thanks again for these good points.
Yeah.
I'm not really sure what I point to add to the discussion other than a couple of remarks I'd like to make. For the case of Python adoption, I do want to remind people that way back when, we're talking 2002, it had the support of the chief architects of both LHCb and Atlas. And so there was, of course, a big push from that side. Now, originally, it was only meant to be interactive access to the Gaudi framework, but that high-level support has been there from the beginning, which is different than what I see developing here from the grassroots. So there would be a different way that the adoption can or should happen. But the point I'd like to make is there is this project which is being started by Fazil, who you all know as the author of Kling, which I put this in the chat, and I think Benjamin forwarded this. And what he's trying to do is to abstract what Kling is and move these pieces into Clang, so in LLVM. And so, this might trickle down the other way back again into Julia as well. And what we have there is we're trying to have this ability of using all kinds of languages, say, for example, in the Jupyter Notebook, both ways and back. And this is a 3-year project, and there's still some time to go. But right now, the languages that we have is Python, obviously. We have D and we have Lisp, and it would be absolutely great if there are Julia people interested in joining this project and making sure that all this stuff works for Julia as well. For this particular audience, in terms of adoption in HEP, since this is stuff that goes into LLVM and then trickles down back to Kling and then into Root, it means basically all of Root and probably most of the experiment frameworks would then be available in Julia natively if we can make this happen. So if anybody is interested, it would be great. In terms of how difficult it would be, since we already tried this out, this is from the past couple of days, to use CPPY through PyCall. Since PyCall provides you a good interface of mapping Julia thingies to Python thingies, and since CPPY knows how to do Python thingies to Cling thingies and basically libinterop, which is then going to be Clang REPL in official LLVM, it should not be hard at all. And to anybody who's enthusiastic and just looks at the code and says, hey, this is the straight shortcut from the Julia thingies to the Cling thingies without this Python layer. And then you would have a tool that is the equivalent of cxx.jl, but then without accessing LLVM directly and therefore not dependent on the specific LLVM version of Julia, and therefore in principle more maintainable. And then again, for this particular audience, it means access to your data because it's Cling, and so root of everything was there. Most likely access to all your framework, and that should really put you into business.
Thank you. That sounds like a very good, and thank you. Well, it's not an advertisement. I think it's very fair that you put on the link. It's on the chat, so I hope everybody can see it and open the browser if they want to check it out properly or offline. Thank you again for that. Very good. We still have a couple of minutes. I don't know if maybe. Yeah.
Maybe I could just. I didn't see any hands, so I'll just unmute. Let me video. Yeah, so I agree with almost everything that was said, especially about, I think the key point is about the ecosystem. I mean, I've been increasingly convinced that this is a language that's far superior. It kind of marries the best of the performance C and the accessibility of Python. But I think the key thing is about the ecosystem. So we were just hearing about the, tying into root and the frameworks, and that's great. But in terms of the analysis side, I mean, I think it's really the adoption, or it's so easy to integrate. There's a huge ecosystem around machine learning frameworks for Python, right? And so I was just wondering, I mean, thinking about building bridges and tunnels, and you want to know, what does it look like? What are you building to this little sandbar, or is this huge thing that you're going to build to? So maybe outside of HEP, does anyone know or could give some insight on sort of, I mean, HEP is we think we're big, we're really a small community, and we're not a driver in a lot of this. And in terms of adoption of collaborations, I think the analysis, the strong adoption by physicists who are doing analysis that are unconstrained by most of the collaboration aspects of, integrating into large projects, software projects, I mean. So what would really drive, I think, people to play around with Julia and, well, not play around, but just adopt Julia and what their precious time in developing some package are going to go to Julia would be the availability of the ecosystem more generally. If I can't find things to link against, I have to then write them. And maybe if I write them natively, I do better, but I don't really want to spend that time. I want to do the physics. So does anyone have an idea of where outside of HEP the field is going in terms of adoption of Julia as a language, and whether the machine learning frameworks are when they will be equivalent to the Pythonic ecosystem around machine learning?
So on one side, they have far exceeded the Pythonic ecosystem. That's if you look at the SciML organization. So the scientific machine learning, there is a very strong drive behind neural ODEs and integrating the differential equation solvers with the language and with the automatic differentiation. So I think that is at least on par with Python. And so in those fields, the infrastructure is very, very good. And as I've shown, there's this diffeq Pi, I think it's called, which uses the whole differential equation solver ecosystem and makes it available to Python. But all of this is written in Julia.
Jerry, since you have not spoken yet, maybe I'll let you continue with that. There's probably many things that we will not manage to discuss today, which is a good sign anyway. But please go ahead.
No, yeah, that's. I was just trying to answer. Can everyone hear me? I don't trust Zoom very much. Okay, yeah, I just want to follow up on the question about where other fields are going on adoption of Julia. So there's this Clemma at Caltech. They're running Julia on super computers, modeling climates. I also know that there's astrophysics people, actually observational astronomy. They do like objects clustering with Julia, and I guess this has been advertised somewhere. Basically, Julia is the first dynamic language to reach 1 petaflops, like being a pure language. And on the other hand, on the other side, which is how like different packages play with each other and an ecosystem about machine learning or statistics, what I want to point out is that like the reusability and extensibility of Julia code is really exceptional. Partly because kind of there's no this drawback of foreign calls, like you write stuff in C++, so other packages you write has to inherit some kind of class that's glued back ultimately to C++. Also partly because of multi-dispatch, it makes it easy, very easy to reason about, especially like what we do is we think about processing data. So it's really easy to reuse someone's library, like reuse two libraries that they don't mutually know each other. I will give one example. There's this library called measurements that knows how to deal with error propagation. So it has a number type defined that can do error propagation when you add, multiply, subtract numbers. There's also this package that solves differential equation, as we all know. So with minimum effort, really, you will be able to quantify errors on your solution of the differential equation solver, because all differential equation solver does is doing number crunching and stuff. Of course, it's hard to, when you have asymmetric errors, whatever, it's going to be more tricky to get it correct. But the idea is that you can have totally mutually like they don't depend on each other or whatever, and they just work. So it's the ecosystem is more mature than if you're trying to find like a TensorFlow for Julia. It doesn't exist because it doesn't need to exist. We don't need 200K line of code in one repository just to do these few things. You can use existing stuff and it will just work.
Okay, thank you. That was quite certain. So we're getting to the end, and just to be also nice to those that are in very far away time zones in Australia. We're going to stop very quickly. Benny, I saw you raising your hand, so if you have maybe a final comment before you need to offline.
I had a question about its use in astrophysics, because obviously astrophysics with AstroPy has led a lot how things like NumPy and other core bits of Python evolved. So I'm curious about it there. I also wanted to highlight that there is one question that came up on Slido, and that's a quite simple one that maybe we could take instead of my one, and we can take it on to Slack. But it's up to you, Eduardo, as chair of this. I think you're muted.
Okay, sure. Which one? There's 5 of them. 4.
They're all about the same. The basic question was, is Julia free and open source software?
Completely free and open source, yes, indeed, with proper licensing or kind licensing, I guess. That's what people want to know. Jan, do you want to reply to that quickly?
Well, it's as free as Python. Short answer.
Yeah, I thought it was completely free. There's no like it's a FOSS community, a FOSS and friendly community. All right, thanks so much.